Okay, in this podcast, we're going to do some reaction coordinate diagrams. Okay, so first off, remember that a reaction coordinate diagram is going to show us the change in energy throughout the course of a reaction from the very beginning to the end. So from reactants going all the way to products. Okay, so just to remind you, the distance between the reactants and the very top of the hill, that is your activation energy. And then the distance between where your reactants started and where your products ended, that is your enthalpy, your change in energy for the whole reaction. All right, so endo versus exothermic. Again, this all depends on if the reaction absorbed energy or released energy overall. So just to remember, recap for you, okay? Reactants having a higher energy than products, that's going to be an exothermic reaction. And if reactants have a lower energy than the products, that's going to be an endothermic reaction. All right, now reverse reactions. Remember, in equilibrium, reactions can go in both the forward and the reverse direction. So in order to look at the activation energy and the enthalpy for the reverse reaction, you kind of have to think about things from the opposite end. So on this picture, you see there's this one's a endothermic reaction pathway, and understand that the distance between where the products are and the top of the hill, that's the activation energy for the reverse reaction. While the distance between where the reactant started and the top of the hill, that's your forward activation energy. Okay, so you have to look at things backwards when you're looking at the reverse reaction. So from products to the top of the hill, that's your activation energy. Please understand that the number for your delta H, your enthalpy, your change in energy for the reaction, it stays the same, but as far as the actual number itself, but it changes sign. So like in this example, this is an endothermic reaction. So the delta H for the forward reaction is positive, but the delta H for the negative reaction, for the reverse reaction is negative, okay? Because it's going from products to reactants instead of the other way around. So when you go from products to reactants, you actually lose energy, which is why it's the negative. Okay, and then this other one over here is showing us a reaction coordinate diagram for an exothermic reaction. So again, start with the products, top of the hill, so distance from products to the top of the hill, that's the activation energy for the reverse reaction. And, you already knew this one, but from reactants to the top of the hill, that's the activation energy for the forward reaction. Again, delta H, the value of it stays the same, but it reverses sign. So in the forward reaction, this is an exothermic reaction. But if you are doing the reverse reaction, it's definitely going to be a endothermic, so a positive delta H.